Good morning everyone. Welcome to today's maths class. We are in the chapter surface areas and volumes and we are doing the problems from the exercise 13.3. Now we are at the fourth problem. A well of diameter 3 meters is dug 14 meters deep. See, look at this red color one is a well. Its diameter is 3 meters and its depth we can consider as height, that is 14 meters. The earth taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meters. Now, see, the soil which we get from the well was spread out like this around it. See, in the green color it is there. Okay, it was spread out like a ring around the well. Okay, now find the height of the, and actually around it in the shape of a circular ring of width 4 meters. The width of the circular embankment, that is called embankment. Okay, so its width is 4 meters. So observe the green color portion which is embankment arranged around the well with a width of 4 meters. Find the height of the embankment. We have to find its height. Okay, now here look at this. This is the fourth problem. Diameter of the well D is equal to 3 meters. Therefore, radius R is equal to, we can say 3 by 2 meters, that is 1.5 meters. Okay, now depth of the well. Depth of the well is equal to D. Let us consider it as the height of the well. We can take it as mathematically, we can consider it as height. So how much it is? 14 meters. Now, width of the embankment W is equal to 4 meters. Okay, and now you have to observe here the embankment has inner radius and the outer radius also. Inner radius is smaller. Outer radius, if you want to get the outer radius, the inner radius of the embankment R is equal to same as the radius of the well, that is 1.5 meters. In the same way, the outer radius of the embankment is equal to capital R. We get it by adding small r plus w, that is the outer radius. Small r plus w, that is equal to 1.5 plus 4 is equal to 5.5 meters. But did you understand? So if you observe the green color portion carefully, you can see the smaller and capital R. Smaller means inner radius of the embankment, capital R means outer radius. We will get it by adding smaller and W, inner radius and width of the embankment. Okay, now we have all the dimensions of the well and the embankment. Now we need to find the height of the embankment. Okay, now you observe here we can say that the embankment has been made by the soil which we get from the well. Therefore, we can say that the volume of the soil we get from the well is equal to volume of the embankment. So why? Because the embankment was made out of the soil which we get from the well. So therefore, the volume of the soil we get from the well is equal to volume of the embankment. What is the volume of the soil from the well? What is the shape of the well? Observe the red color one which is in the cylinder. So we can take it as pi r square h. Okay. And at the same time, what is the volume of the embankment? The embankment is in the shape of a cylinder with a circular, the base is in the shape of a ring. Okay, so we can say that, so the volume of the embankment is pi into pi capital R square, and here I have taken the h as capital H minus pi small r square h. Okay, so for your better understanding, I will draw once again. See, the embankment is, see, like this. So the base is like a ring. Okay, the base is like a ring. So this formula we have to use for the volume of the embankment. Now we can cancel. See, sorry. First of all, write like this is equal to. Let us take pi common. Is equal to pi into capital R square h minus r square h. Okay. Now let us cancel pi and let us substitute the dimensions, the values of the radius and height. Now what is the radius? 1.5. Okay, let us write it as 3 by 2 into 3 by 2 into small h. Small h is the height of the well, that is 14 meters, is equal to capital R square h. So capital R square h, capital R is 4.5, 5.5. 5.5 into 5.5 into capital H, that we don't know, we need to find it, minus small r square, that is 1.5. 1.5 means, let us take it as in the fractional form, 3 by 2. 3 by 2 into 3 by 2. And small h is 14. Okay, small h is 14. Sorry, here also capital H. Okay, now let us do one thing. Let us simplify in another way which will be easy for us. So let us take pi common. Pi already we have taken common, and if you take h also common, we will get r square minus small r square. So the pi will be cancelled. Now r square h is equal to capital H into a square minus b square formula. We can use r plus r into r minus r. Okay. Now what is small r square? Small r is 1.5. Otherwise we can write 3 by 2. 3 by 2. 3 by 2 into h is 14. Capital H we don't know. Capital R plus small r is 5.5 plus 1.5 into 5.5 minus 1.5. Okay, it is easy for us. So the previous one also okay, but it is easy for us. Now 3 by 2 into 3 by 2. So then let us take it as 9 by 4 into cancel 2 7 14. So 3 3 9, 9 7 63. 63 by 2 is equal to h into 5.5 plus 1.5 is 7 into 1.5 minus 5.5 minus 1.5 is 4. Now we need to find out the capital H value from this. So can I erase these first 4 steps? So let me continue this. Here h into 7 into 4, 28 is equal to 63 by 2. Therefore, capital H is equal to 63 by 2. This 28 will be in the denominator. Now, 7 4s are 28, 7 9 is 63 is equal to 9 by 8. Okay? So, if you divide, you will get 8 1 is 8. So, 8 1 is 8 and again if you divide, finally you'll get 125 meters. Therefore, height of the embankment is equal to 1.125 meters. Okay, did you understand? Please copy this problem. Now fifth problem. A container shaped like a right circular cylinder having diameter 12 centimeters and height 15 centimeters. There is a cylindrical container. Okay. Now in this full of ice cream. So it contains ice cream. Okay. The ice cream is to be filled into cones of height 12 centimeters and diameter 6 centimeters. There are small cones like this, many cones are there. Okay. So in these cones, the ice cream has to be filled. Okay. Now, having a hemispherical shape on the top. Whenever we have ice cream outside, ice cream cone, the cone will be filled with the ice cream, and on the top of the cone, they keep some scoop like a hemisphere. So it has to be filled like this as a hemisphere also at the top. So this ice cream has to be filled into some cones like this. So here we need to find the number of such cones which can be filled with the ice cream. Now how many number of ice cream cones we required? So this information I have drawn like this. See, here I have drawn the same diagram clearly. Now you look at this. Here, the diameter of the container. What is the diameter of the container? D is equal to 12 centimeters. Therefore, its radius. Therefore, radius is equal. Let us take it as R1. This is D1. How much it is? 12 by 2, 6 centimeters. Okay, and height. Height is given. Let us take it as H1. That is 15 centimeters. Now, diameter of each cone. D2. Let us take it as 5. It is given as 5 centimeters. Therefore, what is the radius? 5 by 2. That is R2, radius second one. So that is R2 2.5 centimeters. And its height. What is the height of the cone? Each cone H2 is equal to, how much it is given? Here, this is H1, this is H2, this is D1, this is D2. Is equal to 12 centimeters. Okay. Now, what you have to observe from the given information? The volume of the ice cream contained in the cylinder is equal to volume of the ice cream filled into all the cones. Okay. So, volume of the ice cream, volume of the in the container is equal to volume of the ice cream filled in the cones. So from this we can say, therefore, number of cones required is equal to volume of the container. The volume of the container which is having the ice cream by volume of ice cream in each cone. Okay. Now, say let us find volume of the container. What is the shape of the container? The shape of the container is a cylinder. So is equal to pi r square h square units. So this is volume, so cubic units. So pi value has not given, let us take it as 22 by 7 into R1 is 6 into H1 is 15 centimeter cube. Okay, this is, so 6 15 is 90, 90, 6 ja 540, 542 is so 11880 centimeter cube. This is the volume of the container. Now volume of the ice cream in each cone. Okay, see here ice cream is served in as a, it is filled into the cone and it has been also put a hemispherical shape at the top. So this is the combination of cone and hemisphere. So is equal to volume of cone plus volume of hemisphere. Okay, let us do here. Therefore, this is equal to volume of cone formula 1 by 3 pi r square h plus volume of hemisphere formula 2 by 3 pi r cube. Here r is taken as r2 and h is taken as h2. Okay, now let us take 1 by 3 common and pi common, then we get, and r2 also we can take common, r2 square we can take common. Here we get h2 plus here 2 r2. This is cubic units. Now let us substitute the values 22 by 7 into r2 square. What is the radius? 2.5. Otherwise we can write it as 5 by 2 into h2. Height of the cone is 12 plus 2 into r2 is 5 by 2 centimeter cube. Now here 2 will be cancelled. Here 2 11s are. So this is equal to 11 5 is 55. 55 into 5. 275 by 3 7 is 21, 2 is 42 into 12 plus 5, 70 centimeter cube. Okay, let me check once again. Here 1 by 3, 20 times 7, 5 by 2, 5 by 2, H2 is 12 and 2 into R2. Okay, 2 to cancel. Here 2 11 is 11 5 is 55, 55 5 is 5 5 is 25, 5 5 is 25, 27, 275 by 3 7 is 21, 21 2 is 42 into here in the bracket 12 plus 5, 17. Okay, up to here did you understand? Sorry, here the diameter of the ice cream cone is not 5 centimeters, it is 6 centimeters. So R2 is 6 centimeters, D2 is 6 centimeters, therefore R2 is 3 centimeters. Now let us substitute once again. Here 1 by 3 pi 22 by 7 into R2 is 3 into H2. H2 is here 12 plus 2 into 3 centimeter cube. Okay, now 3 will be cancelled. Here 22 3 is 66 by 7 into 12 plus 6 18 centimeter cube. Okay. Therefore, number of cones required is equal to volume of the container. How much did we get? 11880 by 7 by, and volume of each cone we get 66 by 7 into 18. So this is the number of cones. Let us cancel the denominator. Now in 11 table 11 6 11 1080. Okay. Now we get 1080 by 6 into 18. Okay. Now in 9 table we get, I think it is divisible by 9. So 9 2s are 9. 1s are 9 2s are 120s. Now again 6 20s and 2 10s. Finally we get 10. Therefore number of cones is equal to 10. This is the answer. Okay, please copy this problem along with these diagrams. Okay.